Oops. Sorry, that is like really loud, more loud than usual. Hey, we're ready. We're ready to get started. Thank you for coming on out tonight, you guys. I know the weather is supposed to get kind of nasty out there. I'm concerned about it as well, as I'm sure you all are. So what I plan to do is periodically stick my head out the door and see if it's getting really crazy out there. And if it looks like it's getting unbelievably bad, then I might start shuffling people out of here. Just to keep people safe. But I drove over, not too long ago, as you all did, and it wasn't that bad out there right now. So, I'll keep you posted on updates. If anybody else has any info, feel free to pass it along. We'll keep an eye on it as the night goes on and deal with it if we need to. The other thing I was asked to remind you of, there are still a few people who have not filled out the code of conduct. So if you have not done that, please fill out the code of conduct as soon as possible. So we've gotten great results on the first deadline that happened just yesterday, I believe. So we did not lose very many people at all, which is fantastic. It's absolutely fantastic. Congratulations. But we had some people who submitted the assignments never filled out the code of conduct. So make sure you do that. We're not going to kick anybody out of the class because of that necessarily, but we do want you to take a look at that and fill it out. So if you haven't done so already, please make sure you take a look. Trying to think what else. So we do have more hard deadlines coming up, but the next one's not for a little while. I think 4 or 5 weeks from now is the next time where we've got another one of these deadlines that you have to hit before you can move on to the next part of the class. That being said, there are assignments. I think the next assignment's due next Sunday, I want to say. Check the Canvas page for the exact information, and we do expect you to complete those on time. If you fill out if you get stuck on one and you turn in a little bit late, if that happens a couple times, that's not going to be held against you, right? But in general, we do expect you to keep up with the class and keep turning in these assignments on time. So make sure you're staying on top of those things, and we'll let you know when the next big deadline's coming up at the end of Unit 1. Are there any questions about logistics or scheduling stuff or anything like that before we hop into today's review? Any questions? All right, cool. Let's go ahead and hop right into it. There are two major topics for today's class that I want to talk to you about. The first topic was exceptions. So let's just go ahead and set the stage. Start out with the basics. Can somebody explain to me what an exception is in English? What is an exception? It's another one of those words, kind of reoccurring theme where in English we know what this word means. We've probably used it before on a regular basis, but when we talk about it in the context of computer science, its meaning takes on a little bit of a different form. Yeah?
It tells the code what to do when it has an issue.
When it has an issue, yeah, so we tell the code what to do when it has an issue. What do we mean by an issue? Can we be a little bit more specific than that? You're not wrong. I'm just looking for maybe a little bit more detail. What's it? Yeah. Out of the ordinary is a good way of describing it. The textbook, I think, does a good job of saying that it could be that something's gone wrong, right? That definitely qualifies, but it doesn't necessarily have to mean that something's gone wrong, right? Sometimes it just means that we saw something that we didn't necessarily expect to see. It's maybe not necessarily a problem per se. It's just something a little bit unusual, and we don't really know what to do. So we're going to hope that somebody else knows what to do, right? Some other part of our program knows what to do, which is perfectly okay. It's perfectly all right. So exceptions are unusual things that happen. So how do they affect the flow of control of our program? This is something that we've seen a lot of over the first few weeks. We introduced these concepts to you, knowing, we started out very basic. We like a book, right? Top to bottom, left to right. And then we slowly broke that. We started doing things like repetition. We started doing things like choosing paths one over the other. We started using functions, which has a totally different kind of flow. So how do exceptions fit into this idea of control flow? What are exceptions going to do to the flow of our program? How do we deal with that? Yeah. It's like a portal from the video game. I know what you're talking about, but for those of us who may not have played the classic video game Portal or its sequel Portal 2, can we describe it in non-Portal terms, perhaps? Yeah, go ahead. I like that word interrupt actually quite a bit. I like that word interrupt a lot. We're chugging along, doing our thing, right? And then all of a sudden this unusual thing happens, right? Maybe we're not necessarily expecting it, or maybe we kind of think it could happen, but we sort of hope that it doesn't, and then it does. And then we interrupt our flow of control, and then where do we go from there? This exception happens, we have to do something about it. Where do we end up? Where do we end up? So that's one answer, is the accept block. That is one possible answer, is at the accept block. We'll talk a little bit more about that in just a second. What's another possible location for us to end up at? If the program could crash, right? The program could come to a screeching halt. That's another option. If I'm in one function and I don't know how to handle this exception, what am I going to do with it? Where am I going to go? I'm going to go back to the last function, right? The last function I was in, and see if they know what to do. And if they don't know what to do, where am I going to go? I'm going to go back to the one before that, right? So we have this idea of throwing an exception. That means basically a function saying, this happened, but I don't know what to do. Here, you deal with it, right? And it keeps passing along that chain of command until eventually one of two things happens. We get to a function that knows what to do with it. In other words, we find a proper accept block somewhere, or nobody knows what to do with this thing, and so your program just says, well, can't do anything else, we're done, and it crashes. Your program stops, which is probably actually what you've seen the most of up until this point, right? And spoiler alert, you're going to keep seeing it. It's going to keep happening. Happens to all of us all the time. But hopefully as time goes on, you'll get more familiar with the reasons why this thing happens, and you'll get better at deciding what to do when exceptions crash your program, and hopefully get to the point where they crash your program less often. They will never, your programs will crash, right? That's still going to happen. But hopefully you can get to a point where they crash less often as a result. So what are some examples? I know the textbook had a whole huge list. I don't expect you to remember every single thing on that list. What I'd rather talk about are some exceptions that you've seen as you're doing stuff in your code. I know we talked about this a couple weeks ago, but we've done a lot more stuff since then. So any new wonderful exceptions that you guys have seen in the last couple weeks? So I've been working on turtles, and what else did we do in the last week? Loops, stuff like that. What exceptions have you seen in your code? Divide by zero. Oh, that's always a good one. Yeah, in math, dividing by zero is undefined. So it's always surprised me that, when you try to divide by zero on the computer, it doesn't like create some black hole that just swallows us all up and absorbs us. Thankfully, that doesn't happen, but you can't do it. It's not allowed. What else? What other stuff have we seen?
Type errors.
Type errors. So what happens when do we see a type error? When I expect one type of thing to be here and it's some other type instead, right? Maybe I'm trying to divide by zero, and instead of giving you a number, I've given you a string. Well, how do I divide strings? I don't. That's not a thing. We don't do that. So that would be an example of a type error. What about undefined? What was I going to say? I got the first half, and then my mind just totally went blank. Yeah, an undefined variable error. That's probably not what it's officially called, but that's sort of what I was thinking of. We've seen those a lot recently. Why do those happen? We don't initialize them, but more specifically, I think I've seen people who do initialize variables and then they see this error and they're like, what the heck, this thing's right here. When does that happen? It's outside the scope, yeah. If I define a variable here in this function, I try to use it in this other function down here, I'm gonna see that error because the code doesn't know, right, that I put it up there. It's outside the scope. So I might see that error as a result. Or the other time you might see that error is if you just flat out forgot to define that variable anywhere, right? That's perfectly acceptable too. So yeah, the list is a mile long. I'm not going to go through all of them. That's not worth our time. But I think hopefully what we're trying to get you to learn out of this particular unit is that if a problem happens, right, you can decipher those messages. You can figure out what it means. It might look a little confusing at first. You might not understand all of the terminology at first. But A, it's documented somewhere. Somewhere somebody has written these things down in a way that you can understand. And B, as you go along, actually, you'll need less and less of that help. You'll be able to look at an error message and kind of reason about it, think about it, figure out what it's telling you, and go back and fix your code accordingly. You know, your code's going to break, your code's going to crash, and figuring out how to fix mistakes, I think, is more important than being able to write correct code. Because I'm going to make mistakes a lot more often than I write correct code. It's true. I'm going to make mistakes a lot more often than I write correct code. So I need to know how to fix them. All right. What is a try except block? What is that for? What's the try part for? What do I do with that part? Yeah, go ahead.
You're telling your program that there's going to be a part where it might have an issue.
So if I expect something weird to happen, out of the ordinary to happen. Yeah, so user input's a great example. Who knows what those people are thinking, right? Users. What? So if I expect that something odd might happen, I might get some undefined behavior or some weird behavior. I can put it in this try block. And then what does that provide for me? What benefits do I gain from using that try block? What are the advantages of that? Why should I even bother? Kind of goes to the next section a little bit. What's the except block for? I know, you know. Can I get somebody else? Yeah, in the back. Yeah, so if we run into a problem, right, then I'm going to do whatever's in the except block. So that except block could be fixing the problem. That except block could be printing out some information about the problem so that we can try to fix it later, right? That except block, believe it or not, can have problems of its own that need to be handled by other try except blocks elsewhere in your code. It can and will happen. But basically, the try statement really means give it your best effort, right? Try and do this thing. I really think it's going to work. I hope it's going to work. I expect it to work. Most of the time, you're not going to have any problems. And if something goes wrong, here's an except block that you can use to try and handle those particular situations, right? So this next question is maybe the most important one on here, actually. When should we be using these? Should I just start sprinkling these all over the place? Should I slap them in? Should I just start putting my entire program in a try block and then having a catch block at the end? Does that seem like a good idea? See some people shaking their head no. Why? Why not? I'm sorry? When a loop could do the same job, or actually this feels less like a loop and more like an if statement to me. Yeah, try catch block feels a lot like an if statement to me. They're not exactly the same. I don't want you to walk out of here thinking they're the same thing. They're not. But sometimes an if statement can do the job that you're doing with these try catch statements. What's an example of that? What's an example? Yeah. Mm-hmm. Yeah. Yeah. So instead of allowing it to divide by 0 and then dealing with the exception, why not just check to see if the thing is 0 first? and then not doing that thing if it is, right? If I see that I have 0 and I'm about to divide, I just won't do it, right? I just won't cause that problem at all. I can check for that kind of thing. So those kinds of, we call them validations, might be what you hear them called a lot of times, is validations, are common things that we can solve with if statements or actually with loops. I know you brought it up before, but we can solve them with loops a lot of times as well. User input is another great thing. If a user gives us garbage, right, that could very well be a problem. If they give us something that we're not expecting. Should I throw an exception and bring my whole program to a stop just because some user typed in something that I wasn't prepared for? Have you seen programs that do that? You type in something that's a little strange and the program just says, I'm done. What does it usually do instead? Hopefully, if it's well written. What is it usually going to do? Yeah. It's just going to ask you again. We're just going to ask you another time until you get it right. And if you never get it right, I'll just sit there forever and keep asking you, right? It's up to you to figure out how to type in the right stuff. So, there are cases like that when exceptions are not necessarily the right tool for the job. So what is a case where exceptions would be the right tool for a job, or a try-catch block would be the right tool for the job? Does anybody have an example? When we should be using this structure? There's a classic one. I'm pretty sure it was in the text, though it's certainly not the only reasonable time to use try-catch blocks. If I'm doing some kind of a work with a file, right? Doing some kind of work with a file, I need to know where that file is. But that file could get deleted, could get moved, somebody could change the name of it, right? All kinds of weird things could happen to that file that are outside of my control. So this is a perfect time for a try-catch block, perfectly acceptable place to use a try-catch block. Try to open this file. Here's where I think it is. Here's where I think it is. If it's not there for whatever reason, it got deleted, it got moved, it got changed somehow, right? If any of those things happen, I'll have an exception that says, hey, I thought this file was here, it's not. I'm either going to, use this default information instead, or not do anything until you put the file back, or some way of resolving that particular issue. That is a classic usage of a try-catch statement. So in other words, right, a great situation to use this is if the error that's being caused is potentially outside of my control. There's nothing that I can really do about it. I can't control what people do with files on their computer. That's not up to me. I can't do that, right? If they do something weird, I can't make them put it back, right? That's up to them. I can't fix that necessarily. So that's a good use of a try-catch. For user input, I can do something about that. I can ask them again. So that's a good resolution. I don't need a try-catch to solve that particular problem. And finally, oh, that was a really weird thing to say. What is a finally block? I didn't mean to do that. You don't have to believe me, but it's true. What is a finally block? Yeah, in the back. Yeah, so do we always run the do we always run the except statement? Does that always happen? No. We always run the try. We at least try to run the try statement, right? Sometimes we run the except, sometimes we don't. What about finally? Always run the finally, always run the finally. But why? Why might we want to do that? Yeah, go ahead.
Close a file. To
close a file, to clean up after ourselves, basically. Let's say I got half of the work done, and then the exception happened, right? Do I just want to leave that half of the work that I already did just chilling there, just hanging out, taking up space, doing stuff I don't even know what it's doing because I got sidetracked by this exception over here? No, I don't want to just leave it there. I want to clean it up. So the finally block is used to make sure that, if a problem did happen, or even if a problem didn't happen, right? You clean up after the work that you did in the try block. You make sure that anything that got partially completed is either entirely completed or undone as best as you can. It may not always be possible, right? There are always times when the situation may be out of our control, but if it's possible to do so, the finally block is a good choice. Cool. What questions do you have about exceptions? What questions? Anybody? All right. If there aren't any questions, we're going to move on to the second part of today's work. And actually, this is going to be a much more interactive piece. You guys need it because you've been kind of quiet this evening, so I'm going to force you to talk and do some stuff to get everybody excited and ready to work on programming problems. So what I'm going to do next is introduce a problem to you, right? In fact, I'll show you a problem very soon. And we're going to go through the steps, the problem-solving steps. I don't want you to write any code for this. I'm not going to write any code for this. I want this to be pure problem-solving. I want you to think about this at a very high level, right? Don't worry about writing code. Don't worry about what the code would look like. I'm not worried about that right now. I want to solve the problem at a high level. And then maybe later on, at the end of class, we'll write the code to solve the problem, right? Once we get a chance to think about this. So I'm going to show you the problem. I'm not going to leave the problem up on the screen very long. I'm going to leave it on the screen maybe 30 seconds. It's not a super complicated problem, right? I'll leave it up on the screen for 30 seconds to a minute. You'll have a chance to read it a couple times. I want you to find somebody in your general vicinity and restate your understanding of that problem to them, right? That's part of the problem-solving process. Make sure you understand the problem by explaining it to somebody else. Make sure that their explanation agrees with your explanation, right? Make sure you're on the same page. And if you're not, figure out what the differences are and try and resolve it. Then outline this problem. Figure out what the steps are that you would need to accomplish. In other words, I like to think of this as almost generating the algorithm, right? First thing I have to do is this. Next thing I have to do is this. Next thing I have to do is this. And then reduce the problem into its component pieces. Those two really go together. The outline and the reducing, kind of go hand in hand. They go with each other. One other thing that I want you to think about, especially for these last particular pieces, as you're coming up with the building blocks of this problem, right? Consider the tools in your toolbox and how those apply to the different blocks, to the different pieces of the problem that you're trying to solve. In other words, right? We're a few weeks into this class. We have a somewhat small tool set available to us, but a powerful one. I can use variables. I can use if statements. I can use loops. I can use functions, right? Figure out how these tools in our toolbox apply to the pieces of the problem that you've identified. I'm not asking you to write the loops. I'm not asking you to write the if statements. Just consider, is a loop the right tool to solve this part of the problem? Is an if statement the right tool to solve this part of the problem, right? Find somebody to work with. I'm going to put the problem up here on the screen just a moment. Find somebody to work with and talk it out for a few moments, and then we'll discuss together as a group. All right, you ready? Here we go. The problem is not that. The problem is not that either. Sorry. I had it up and then I moved away. Here we go. It's a little bit mathematical, but the math is not that bad, I promise. I'm going to leave this up on the screen for a few moments. Think about the problem. I'm going to take it off in about 30 seconds, and then I want you to discuss with your neighbors. Taking a picture is cheating. I see you. It's cheating.
That's a tool, isn't it?
So I'm really not worried about the exact numbers, right? How do I find the largest prime factor of the number? What does that mean? Consider what that means. And get ready to talk about it with your neighbors, because I'm about to take this problem off the screen, right? Talk to your neighbors about it for a few moments. Break this problem down into its component pieces. Think about what the building blocks of this problem are. Break this into smaller parts that you can use to construct the larger solution. I'm going to give you 5-10 minutes. Talk to your neighbors about this. I'll do a couple laps, and then we'll talk about the solution, or we'll go over, a high-level solution in just a moment. All right, have fun.
Hi.
Tim.
You're all here.
So the problem is that we had some big number and we're just fine. So I think
That's the essential one.
So I guess what we just do is find all the factors. So I find out which ones are those factors are into the last one. Our largest those should be the easiest part.
Yeah, we mostly figuring out which of the factors are easy, meaning efficient way.
I feel like sometimes it's obvious.
Yeah.
Up to that number. Because that number divided by itself
Right, but that's right. Well, potentially could be. If we, that number would not be. That number would not be.
That would not be.
So you just have to kind of do it.
You could generate a big old list.
Yeah.
And then go through that.
And then, basically, first generate a list of the factors.
That'd be one function.
Yeah.
Another function.
That would be essentially, hey, for that list, any of the numbers in this list. Basically,
and then you find all the if that number modulo 1.
I guess. Yeah, whether or not use modulo to do it's divided by
what if it's divided by itself in modulo? But if 1 would be the number, so it'd be modulo 0.
No, because that would be divided. You almost have to do right, yeah. Right, there's an easier way to do this.
You could do an array and multiply by each number in an array. So arrays of an array.
Right.
I'm
having a problem figuring out how to just there's that big
right. Figure out what the factors are.
Well, it's not necessarily that's just kind of a simple way to just know it's a prize without having to go through check that.
So you're saying
it's got to be
I feel like that's what it would be, right? Just go through numbers 1 to 12. Right?
Well, you have to go.
We can have to go all the way
up to that number 5.
Right.
Because that would be the at
highest
that point.
you could
That's
do
right.
without repeating.
Yeah, exactly. Otherwise, you basically cross check. So that could potentially at the end of the week.
I feel like that's as far as we're going to go, actually writing.
Without having to think about it. I feel like I have
bunch of loops within loops. At least 2 arrays.
So you goals. Yeah.
And then to find the largest number.
Well, you would take all those terms and finally figure out the prime. And then
you have to assume the prime number.
Right, yeah. Well, first function you have to take that number and return all that's back. Second number would take all that's back and then return all the primes. And then the last function would essentially take all of the primes back.
All right, everybody. I heard some great, fantastic conversations out there. Let's see if we can come to a general consensus on this problem. So there's not, like most problems that we've seen so far, there are multiple ways of solving this. So just because we go through a particular solution up here does not mean that's the definitive solution to this problem, but I would like to try and nail some things down, right? Try and get some idea, move us in the right direction. So let's pull up an empty document here and see if we can't start putting together a high-level solution. I don't want to write code here. I just want to kind of take some notes, right? Take some notes, write down some ideas that we have about this problem that we can then use to help us turn it into a coding solution. So, what are some of the components that we need to do to solve this problem? That's one of the steps, right? One of the steps of the problem-solving process. Can we break this down into smaller chunks? What are one of those chunks? Yeah.
Function that determines factors of a number.
Factors. So we need to have some way of determining factors of a number, right? What's another chunk that we need?
We need to figure out which of those factors will be prime.
We need to figure out prime numbers. So again, I like to try, especially for this piece, right? State things as generally as possible. So instead of, determine whether a number is prime, that could be any possible number, right? I don't care. I know that we care about prime factors. That's what the problem says. But really, it's easier and better for me if I can write a piece of code that determines what a factor is, and I can write another piece of code that determines what a prime is, then I put the two together, right? And hopefully I get prime factors, right? And what other pieces do we need? What other pieces do we need? Yeah. I'm sorry? So we do need, efficiency is a concern. Yeah, efficiency is definitely a concern. This could potentially take a long time depending on the route that we take, although I almost would consider that to be an implementation detail, not necessarily a problem-solving detail, but it is something that we need to concern ourselves with. This is definitely a problem that could take forever. Well, not literally forever, but a long time if we're not careful about how we approach it. Are there any pieces of this problem any other subdivisions of this problem that you can think of? Did I see one over here? I'm sorry? We need to find the largest one, right? We need to have some way of finding the largest number, right? So we need to find largest number in, we could say like this, right? Find the largest number in a list. Although, I think going back to what was mentioned just a moment ago, that if we find an efficient way of solving this problem, this last piece in particular may become a bit more trivial for us. Let's see now. So I think these are good components to consider, unless anybody has huge major objections, right? What I want to do now is dive into each one of these. And again, I'm not looking for code here. Let's see if we can flesh out these ideas a little bit. There's a couple things that I'm interested in. One, what information do I need to solve this task, right? What tools from my toolbox do I need to solve this task, right? And is there any other kind of weird thing that I need to consider? Any other kinds of weird conditions or weird situations that I might expect to run into while I'm solving this task? Those are the kinds of things that I'm looking for. So let's start. What was the first one that I said? What was it? I can't even remember what I said 30 seconds ago. What information, yeah, thank you. What information do I need to solve this problem? So what pieces of information do I need to solve this particular problem? I do need to understand this idea of a factor. Yeah, I do need to understand that idea of a factor. Yes, I need the number. So what number am I taking the factor of, right? So, Right? What's the result of this going to look like? What do I want the result of this to be? Yeah, a list, sure. Right? Okay. What tools do I expect that I'll need? Notice here, actually, what have I really defined? This is an input, or what do we call that in computer science? Parameter. This is a parameter, right? I also would have accepted argument in this case. I know we talked about how those are similar but different. And then what is this? Gives back a list of factors. That's the output. That's the return. So I've basically defined, here's what I need to do my job, and once you give me that information, here's what I'll get back to you, right? What tools do I need to solve this? What tools in my toolbox do I need to solve this? Yeah. Modulus is, okay, so some form of modulus will help us, I agree. That's an operation. How does that help us specifically? How do I know, how does modulus tell me if I have a factor? What am I looking for specifically? If the remainder is 0, then I know I found a factor. So modulus is going to help us here. What other tools in our toolbox are going to help us here? I need a loop. I think I need a loop for sure. And if you want to, try and define some loose range for the loop, right? Where's the loop going to start? Where's the loop going to end? Do we have any ideas about that? 1? Do I need to check 1? 1's always going to work, right? 2 is a good starting point. Where do I need to end? End at the number. Number minus 1, I heard. That'll never work, right? Number minus 1 will never be a factor of the number I'm looking for.
Number divided by 2.
Number divided by 2? I think it's a good place to stop. Number divided by 2 is the most intuitive one. I think square root, I heard somebody say, I think that'll actually work, but I'm not going to take the time to spell out the math of that. That's a different time and place. The number itself we can assume is always a factor, right? We know that. Oh, if the number is actually prime?
Well, wouldn't that just be one of the exceptions you check for?
Would that be an exception? Oh man, now we're getting into some great. So in some sense, I think you could argue that this problem is a little poorly defined, right? Do we expect prime numbers to come in? Is that something that we expect? We could check to see if the number is prime first, and if it is, but right now, do we care about primes? Right now, is prime something that we're worried about? Right now, we're just worried about finding factors, right? And actually, I don't need to check whether the number itself is a factor. I know it is. It always is. So if you're asking me, should I put n on the list? The answer is yes, right? Whether n is prime or not has no effect on my answer to that question. N is always a factor of itself, whether or not n is prime, right? So we don't need to worry about that. That's not a concern for us. That's just sort of an automatic thing that we can do. So maybe you like the bounds of this loop, maybe you don't. It's a starting point, right? It's a place to begin. It's a place to begin. What other tools do you think that we need? I think there's one tool that's going to kind of have to go along with this one. We need some kind of an if, right? We'll use an if statement with the modulus. We'll use a loop to run through the, what does this loop represent? Using a loop to run through possible factors, right? What other tools do we need? I think we're pretty good. I think we're pretty good. Again, is this complete? Do you agree with it entirely? Maybe, maybe not, but we're trying to get a good starting point here, right? Trying to write down as much information as we can and to give us as much of a head start as possible. Yeah?
You need to have it make a list of the ones that are factors.
Yeah, so I mean, if you want to explicitly say that out, you can, but this is sort of implies that we have to do that. Just having this list of factors sort of implies that we need to create that list. But I agree with you, you know, that is something that needs to happen, absolutely. And again, there's no right or wrong way of doing this. I actually tend to be a little bit more loosey-goosey about this than other people who really want to get in and nail down each individual detail. You'll find your own style. All right. I don't know if I'll do all of these, but let's at least do this next part. I'm trying to be a little conscious of time. How do I determine whether a number is prime? The factor is 1. Well, 1 is a factor of everything, right? So that's part of the solution, but it's not the entire solution. No factors but 1 and itself. Yeah. So basically, actually, do you see how I could use this piece to help me solve this piece? Yeah? What would that look like? How can I use this to help me determine the answer to this? If it doesn't return any factors, close. How many factors would I expect if it's prime? 2, 1, and itself, right? So if, you know, a number has 2 factors only, right? Only 2 factors. It must be prime. And we've actually done a great thing. What is this called when we use part of our program to help us solve another part? We have a name for that. I'm sorry? No, not recursion. Not recursion. We are using a function, but what does it mean when we use functions within other functions to help us solve larger problems? We're calling it, we're doing composition, right? We're doing composition. We're taking a bunch of behaviors and putting them together to solve a larger problem, right? Sorry if I missed you over there, my bad.
Oh, no, I didn't feel like reading it.
Yeah, that's all right, I understand. I have a microphone if you want to borrow it.
Yeah.
No, I'm just kidding. Yeah, question.
So are we determining whether any number is prime or from the list of factors we have?
Yeah. So when you're focusing on the, I might call it like a sub-problem or the smaller pieces, right? I'm keeping it as general as possible. I want to know if any number is prime. Later on, I can then say, well, I actually don't, you know, these are the numbers that I'm specifically interested in. But I don't want to limit my function to just solving primes for certain values, right? That's not as useful to me as having a function that can check any value to see if it's prime. And another way of thinking about this is, I know I'm taking the primes of factors, but do I know what those factors are going to be ahead of time? No. So I need to be prepared for anything, right? So solve the general question of how do I know if a number is prime? And then later on when I say, okay, now check if these exact numbers are prime, I know that my function will be able to handle whatever I throw at it, right? Keep things general, solve things in a very general sense, and then use those building blocks to construct, to solve the problem. Real quick, we'll do one last thing with this, and then I'm not going to code this up, at least not right now. I might do it later if we have time, but I'm not going to do it right now. Find the largest number in the list. There's actually a shortcut we can take here. I'm sorry? Go ahead. We can use the max function. So the max function is possible here, right? Or I actually think there's a way that we can approach this problem from a slightly different direction that might help us as well. Yeah. Yeah, it would just be the last one in the list, but so you point out this loop, right? You point out this loop. I'm glad you pointed out this loop, because this loop, I think, what if we, instead of starting from the smallest number and going up, if I'm looking for large factors, why don't I start from the largest number and go down, right? Do I even need a list at that point? Do I even need a list? Find the largest factor that I can, right? Check to see if it's prime, and we're good. I don't even care about the smaller ones. The smaller ones don't concern me. They don't concern me, right? I don't think we need an exception to do that, but we definitely do want to stop after we found. How do we tell a function to stop? Return. We use a return statement. Yeah, not an exception, but yes, absolutely, absolutely. Yeah. If a number has greater than 2 factors, it's not prime. Right here, you mean? What's the distinction?
Because once you get more than 2 factors,
right,
then you can cancel that number out.
Once I get more than... I don't think I disagree with what you're saying. I'm just confused as to is there something wrong about what I had up here, or am I misunderstanding?
I just think it's much faster.
Oh, you think it's faster? I see. Oh, I get what you're saying. Once you found more than 2 factors, don't even bother checking for the rest of them, because I know it's not prime. Yeah. Yeah. Yep. More than 2 factors. So, one in itself, honestly, let's rephrase this. I like your idea. Has more than 2 factors, it is not prime, right? Just restating the problem a little bit. Hopefully we can speed things up. Okay. I'm going to go ahead and pause here. I know that this is not complete, right? We don't actually have the code to do this, but we've talked about the problem. You've come up with some fantastic ideas. I think you actually do have the ability to take what we've got up here and complete it out, finish it the rest of the way. One thing that I would like to mention while we're on this topic, this problem, right, I didn't come up with this. This is from a website called projecteuler.net. I know it looks like Euler, but it's Euler, based after a famous mathematician from a long time ago. And this website, if you're ever looking for more programming exercises, this website's absolutely fantastic because there are hundreds, literally hundreds of problems on here that you can solve, and then it tracks your progress through. They do get very, very hard. So, you know, I think right now you guys could probably do most of the ones on this first page, although once you get down towards the bottom of this page, you're going to be scratching your head for quite a while. But that's a good thing. It's a good thing. Keep you busy, keep you thinking about how to solve these kinds of problems. They're just fun little coding puzzles, basically, right? So if you're looking for something to do, if you finish Studio early today and you want more practice, go sign up for an account, Project Euler. Get through as many of these as you can. Talk to your TFs about them. I'm sure they're aware of this site as well. Yeah, but don't go to page 13 and try these problems. You can see that only a few hundred people have even solved these. That's what these numbers are. And I am not one of them, so don't ask me either. I don't know. I don't know. But this site will definitely keep you busy for a while. All right, one more thing before I turn you loose for Studio. We do have a walkthrough today, a real quick walkthrough. Again, this is sort of what we just did, but with a different problem and a little bit more concrete. I will write the code this time. It's a little bit more satisfying that way to actually write the code. So now we're assigned a different task. I'm going to put a pin in that last task. We're going to take a look at a different task. I'm going to write a function that takes in a list of integers. It also takes in a string, and that string is either going to say positive or negative. And then what I want to do is either print all the positive integers in the list if it says positive, or print all the negative integers in the list if it says negative, right? And so we want to break this problem into its components, but to make life a little easier for us, we actually already have the components in place, right? So level 1 component, and actually this starts out pretty easy and gets more difficult as we go along. You can see the first thing we're going to do is write out a very simple function that prints out, takes in an integer, prints out positive if it's positive or negative if it's negative. Then we're going to take a function that takes in a list of integers and only prints out the positive ones, and then we'll combine the two together and solve the last part here. So first things first, start with the easy function, the level 1 function, right? I'm going to define a function. What should I call this? Doesn't really matter. Print sign, I don't know, positive or negative, right? Print sign. I want it to take in an integer value, so it doesn't really matter what I call this, right? I can call it anything I want. Typical value might be n. Okay, and we can see the behavior that's defined here. If the value is positive, if n is positive, I want to print out positive. If it's negative, I want to print out negative. If it's 0, I don't want to do anything. So what tool in my toolbox am I going to use to solve this problem? I'm going to use an if statement. I keep putting parentheses in there. That's not a thing. If n is positive, I say n is greater than 0, print positive. Oops. What comes next? Else? Else if. Why do I have to do this and not just else? How many cases do I have? That's what we say in computer science. How many possible outcomes do I have? 3. If I do an if and an else, I'm only allowing for 2, right? So this elif becomes necessary if I want to have 3 different situations. Elif what? We want to do equals 0? I think we could do equals 0. We could. It would change the way that this is formatted a little bit. I think it's certainly possible. I think it's a little bit easier. I think it's a little bit more straightforward. I think it's less typing for us. I'm very lazy if we go this route. So print negative. Right? And now I'm going to put in else for 0, right? Yeah? Nobody wants to yell at me? Somebody wants to yell at me. Please yell at me.
You don't?
Don't do it.
Do it.
You don't have to. Why not? Look at what we've got. If n is greater than 0, I'm going to print positive. If n is less than 0, I'm going to print negative. If both of these things are false, then I know by process of elimination that n must be 0. And for 0, I don't have to do anything. So I'm done. I'm done. Let's try it out real quick. Let's try it out. I'm going to come down here and I'll print sign of a positive value, and then we'll try it again with a negative value, and then we'll try it again with 0. I got an error. What did I do? Oh, did I forget parentheses? Is that what's going on? My bad. My fault. There we go, much better. Switch this to a -7, and we've got a negative value, and that seems good. And if we put in 0, right, we get nothing. So far, so good. So this is basically breaking this down so that we can check to see, you know, positive versus negative values, and also understand the distinction that 0 is kind of left out. 0 is not a thing in this scheme, right? So that's level 1. Let's move on to level 2, which has some similarities with level 1, but also some differences. We want to write a function that takes in a list of integers and only prints the positive ones, right? So we're going to create a new function. Actually, I'll get rid of this function call for now. I'll say print positives, right? And I'm going to have an input here, but this time I expect my input not to be a single number, but a whole bunch of numbers, right? A whole bunch of them. I'll call it L. Call it L. So how do I check these? How do I go through and check these to see, you know, the positive or negative ones? What tools from my toolbox do I need to solve this problem? What tool am I going to need? Some sort of a loop. Some sort of a loop. What's this loop going to look like? For I is fine. What comes next? In. What comes next? Range? L. What's the difference? What's the difference? We've seen this before. This is definitely a thing that we've seen before, right? What's the difference between putting a range here versus just putting L? What's the difference? Can somebody explain that to me?
You're calling a specific list.
L will show me what's actually in the list, right? If I loop over L, it'll tell me what's actually in the list. I can actually see all of those numbers, which is what I want, right? I want to see what those numbers are. If I do range, this is just going to give me a count of numbers, right? 0 through whatever, which is probably not what's in my list. It's probably not what's in there, right? So in this particular case, I think you could get there this direction. This is another situation where if you want to type range here, I think you can get there. I think you can figure out a path to the solution going down this road. But I think it's easier and more straightforward for us to do this. So now when I look at this loop, I is going to take on the first time through the loop, I'll be the first number in the list. The second time through the loop, I'll be the second number in the list. The third time through the loop, right? Do we get it? Okay, so what's next? Remember, my goal is I'm going to take the list of integers and only print the positive ones. So how do I do that? What's the next tool that I need to solve this problem? An if statement. Specifically, we're looking for positive ones, right? We're looking for positive ones. Well, hey, that's a thing that we've already done. So this is a great time, I think, to realize that, oh yeah, we've sort of got this already. It's maybe not exactly what we want, but it's kind of what we want. How do I change this to give me what I want?
Change the variable.
Instead of positive, what do I put in here? I. What else? I also need to change n to be I. Everybody understand that? Did I lose anybody? I'm sorry? You've been found? All right, let's try it out. Let's check it and make sure that it works. A simple way we could check this is to call our function. And how do I create a list? That's not something that I know that we've spent a lot of time talking about, but I'm sure somebody out there probably has an idea. How do I create a list of numbers? What do I see in my code? I mean, we do have to initialize the list. What does that look like, though? What do I expect to see? Brackets in my code. If this is seeming very new to you, don't freak out. We're going to talk a lot more about lists later. I understand that this is something that we've not discussed in hardly any detail, but for now, bear with me. So I'll give it some positive values and some negative values, right? And I'm going to throw a 0 in there as well, right? I want to make sure that zeros also work. So everything in between the brackets, that's my list. That's my list. Let's try it out and see what happens. Oops, I screwed something up. The name, the easiest part. The easiest part. I misspelled it both places in different ways. That's how good I am. Is it good now?
Yeah.
Okay. I don't trust myself, but I trust you guys. Hey, all right. I got a 2, I got an 8, and I got a 9. And if I look at the numbers that I typed in there, those are the only positive ones on my list, right? So far, so good? All right. Final step. Final stage of this is to try and take both of these pieces and tie them all together to solve the problem that we want. I'm going to write a function that takes in a list of integers as well as this string that either says positive or negative. And then based on what that string says, we're going to print out the integers that are either positive or negative, right? So let's start with our function definition. Def print, what am I printing this time? I'm printing integers, ints, I don't know. That's maybe not the best name for it, but it's fine. I know that I'm going to take in, right, a list of integers. That's what it says first, list of integers. I'll call that L. I also want to take in a string. That's whether it's positive or negative, right? Positive or negative? I'll call that sign. I don't know. Okay. So there's definitely some new stuff here. There's definitely some stuff that we can use from prior versions, right? Prior functions that we've written. What's first? What's the first tool that I need in my toolbox? What's the first thing that is it something that I'm going to borrow or something new? Where do you think we're going to start? What's step number 1? So L is going to be a list of numbers, not unlike the list that I've got up here. The sign is it's going to be a word. It's literally going to say positive or it's going to say negative. And so based on what it says, I then either need to print out the positive numbers in the list if sign says positive, or if sign says negative, I need to print out the negative numbers in the list, right? Based on those two options. Does that help clarify? We'll call it later once we're done writing the function, right? I'm happy to answer questions. So we could check sign first. We could check to see whether it's positive or negative first, right? That's one way we could approach the problem. And I'm totally fine with that. Let's do that. How do I check to see if sign is positive or negative? What do I say here? I keep using parentheses in the wrong places, sorry. If sign equals can't slip one past you guys. Actually, I can, but I didn't this time. Next time. If sign is positive, then what? I want to print the positives, right? So I can actually use print positives almost directly, right? I don't even need to do anything else here, right? I'm sorry? I need to run a loop on, but when I call print positives, doesn't this loop do the trick for me? Yeah, it does the trick for me, right? So that's cool. Else, or is it elif?
You would have an else in case they type in something weird.
So what if they type in something weird? That's the question, right? What if they type in cheese? Right? What do I do then? I got two options. I can either, actually I got more than two options. I got lots of options, but you know, some of the options that I could consider are, if they type in cheese, I'll just ignore them and say, you have no idea what you're talking about, so I'm not going to do anything, right? That's one option. If they type in cheese, I could say, well, I'll just assume you meant negative, and I'll do all the negatives, right? I don't know what would make you think that cheese is possibly a negative thing, but that's one way you could handle it, right? You could, what else? You guys have been itching to throw some exceptions today, right? You could maybe throw some exceptions, maybe. It's an option. We could ask them to do something else, but we're not prompting them in the first place here, right? In fact, this is kind of an interesting distinction. The input to a function is a different concept than asking the user to provide some input, right? That's two different things. The way I reconcile the two in my head is inputs to a function, I expect a programmer to use those, right? User input comes from anybody. Some guy walking down the street, your mom, you know, whoever it is can type stuff in. And there's a big difference between those two groups, right? Programmers, you have to assume, kind of have an idea what they're doing and are going to try their best to use your function inputs in a reasonable way. And we can also, you know, treat them a little bit differently. If a programmer screws up, I have a different way of communicating that to them, i.e. exceptions, right? That if a user screws up, they don't want to see an exception. They don't know what to do with that. That's not their thing. So I need to be a little bit more gentler to them and say, hey, maybe don't type in cheese. Maybe type in positive or negative. Right? So that's kind of the distinction between the two. Here, since sine is coming in as a function input, right, that means that a programmer is using that, not just some random guy walking down the street. It's some actual programmer. So if they do something weird, I'm going to throw it back in their face and be like, hey, you did something weird here, right? So those are the options. I think actually for the sake of this particular one, I'm going to choose the option where I just ignore it. They type in something strange, I'm just going to pretend like they don't exist. If you don't agree with that option, that's totally okay. It's your program. You can handle these weird situations however you want to. I'm making the choice to just ignore it if they give me something weird. So if sine equals negative, right? Oh, I don't need the extra colon, thank you. That would have come back to bite me eventually, right? So what now? What do I have to do now? So I don't have anything that's going to print out negatives for me, right? I don't have anything that's going to take care of that for me. So there's two things we can do here, right? There's two things we can do here. I can take this loop and just plop it in right here and fix it up and make it good. I can make a second function that says, it's called print negatives, that does all the negative printing for me, right? And honestly, in this particular case, I'm not sure that I'm particularly upset by either one of those options. I'm not sure that either one is going to make me too upset. The one thing that might bother me a little bit is the consistency, the lack of consistency. That might bother me a little bit. Where I'm calling a function here, but not calling a function here, that would bother me a little. So with that in mind, creating a function to print negatives might be slightly preferred by me in this particular situation, but only slightly. If you did it the other way, I wouldn't be upset with you or anything like that. So let's go ahead and do that real quick. Print negatives, and then really the only thing I have to do is put the sign. Now some of you out there may not like this solution that I chose, and again I might be repeating myself a lot here when I say this, but if you don't like this, the way I coded this solution, it's entirely within your right. Maybe you think this style looks hideous and you can't believe that I just created a second function. Why would I ever do that? That's okay. You have every right to disagree with me if you don't like what I did. Design is a very subjective part of programming. Computer science is in the name, but actually writing programs is a little bit artistic. There's a little bit of an art behind it that's not exact, right? That's why there are 100 different ways to solve the same problem, because it's very flexible. So if you don't like this solution, if you think that it looks hideous, or you think that I did it wrong, do it a different way. Yeah?
Would it be faster? Is one way faster than the other?
Ah, great question. Is one way faster than the other? This is such a small problem that I don't think so. I really don't think that one way is necessarily faster than the other. If it is, we're talking by a very small fraction of an amount. And usually, not always, but usually for computer science related things, when we're talking about performance, I'm not worried about saving half a second somewhere. I'm worried about saving lots of seconds or lots of minutes. There are exceptions to that rule. If you work with, programs with very tight constraints like aircraft software or radiation machines in a hospital, then those kinds of things actually make a big difference, and you don't want to mess around with them. But for general stuff like this, I'm not going to worry about saving a fraction of a second here or a fraction of a second there. But I'm glad that you're thinking about stuff like that, because we definitely will run into situations where it'll work, it'll take hours, and that's no good. That's no good. Yeah. No, you're fine.
So I know that they're not in the same scope, but in using L over and over again, is that what happens?
Ah, great question. Question is using L over and over again. Is that a good habit to get into or a bad habit to get into? What do we think? What do we think? Is this okay or not okay? there's two ways of approaching this. One is, will it work? And I haven't actually proven it to you yet, but I hope that I can prove it to you that, it certainly will work if I, I can call my function, I can test it out, right? So using L over and over again will work. Does that mean we should do it? That's a different question. Is it okay stylistically? Is it okay from an organizational standpoint? What do we think? Yeah. Since we're using it in different functions, that actually helps a lot towards answering this question. The big thing is to try, and actually I have not done a great job of this, so shame on me. The big thing is to try and make your variables somewhat descriptive. I chose L for list, right? But that's not super immediately apparent from my code. I was being a little bit lazy. I didn't want to have to type out the word list all over the place, but perhaps I should have, right? And to get back to your question, if that word describes what the variable is doing in multiple different places, then yes, absolutely. Use that same name in multiple different places, right? It's pretty consistent, yeah. The biggest thing is, for variable naming especially, we're not worried about function. We're not worried about, program execution as much when it comes to variable names. We're worried about readability for variable names and function names too, to some extent, right? Choose names that are descriptive of what that thing represents. That is always the best thing to choose, even if it's a name that you've already used somewhere else, right? If that really is the best way to describe this thing, then use it. Use it to describe it. So here, actually, even though L may not be the best name in the world, seeing L show up all over the place actually does kind of show us that, yeah, this is the list. This is the same kind of thing that's showing up in many different places, even if it's not the exact same one, right? It's the same kind of thing. I'm treating it the same way, right? And it can help to see that association. Great question. Any other questions? Any other questions? Okay, so, we're doing pretty good on time. So you do have a studio today. If you finish the studio, I would encourage you to go back and finish up that Project Euler problem that we were working on. See if you can take it and turn it into code. If you finish that up, there's like 13 more pages of those things that you can try and work on for the rest of the time. So get cracking at it. But do the studio first. It's called Sherlock. It's kind of interesting because we give you code this time and ask you to fix it, which is actually a really good skill, really good exercise. As usual, I will regroup us around 8 or so to go over the studio solution. But I am going to keep an eye on the weather. In fact, I'm going to go check it right now, and I'll try and keep you guys updated on that. If you don't hear anything from me, that means things are fine. I'll only bother you if it looks like it's getting really bad out there. So go ahead and break up into your groups and get started on that studio.
Yeah,